What if a robot didn't need a brain to change its behavior? That's basically what this paper is doing. The researchers looked at stingrays, especially how their soft bodies move through water, and used that idea to build a soft actuator that can switch between different motion styles on its own. Not because a computer tells it to, but because the material itself responds differently when conditions change. The robot has three main motion modes: tracking, undulation, and oscillation. In simple terms, that means it can follow light, ripple like a swimming animal, or flap back and forth depending on how energy builds up inside it. Think of it like this. Most robots are like people following a strict to-do list. Input comes in, software decides what to do, and motors obey. This thing is more like a reflex. Change the environment, and the motion changes with it. That's the clever part. The system reacts to things like light intensity, temperature, viscosity, and even physical contact. So if the surroundings change, the robot can cross a kind of motion tipping point and shift into a different behavior. And that matters because traditional robots usually need more sensors, more code, and more control systems to do that. Here, some of that decision-making is pushed into the material itself. This is why soft robotics is so interesting. Instead of building a machine that fights the environment, you build one that works with it. Less rigid, less over-engineered, more like biology. The inspiration from stingrays is especially strong because stingrays move with smooth, distributed body motion. They don't rely on spinning joints like a factory robot. Their whole body helps generate motion. This design copies that idea in a simpler, synthetic form. And this isn't just a cool movement demo. The paper points to possible uses in fluid control, electronics, and environmental monitoring. Basically situations where a soft device could benefit from reacting automatically without a heavy control system. So no, this robot is not thinking, but it is doing something that looks suspiciously smart. And I think that's the bigger shift here. Intelligence in robotics might not always come from better code. Sometimes it comes from better physics. So here's the question. If a soft robot can adapt without a real brain, where do you think this kind of design makes the most sense first? Medicine, ocean exploration, or wearable tech?